Okay, example 6. Okay, in this example, the speed is controlled by two methods. Okay, which is first is armature voltage control, and the second one is flux control method. Okay, and then in this question, there is an expression for torque, which is torque L equal to 500 minus 0.25 m. Okay, torque L equal to 500 minus 0.25 n, where n is a speed. Okay, speed in RPM. So the unit for torque is Newton meter. Okay, the first question is calculate motor terminal voltage and armature current when the speed is 400 RPM. So the rated speed here is at rated. Okay, at rated speed equal to 750 RPM. So for question A, okay, the question asks to calculate the terminal voltage and armature current when the speed is 400 RPM. We know when the speed is below the base speed, this is the base speed, and 400 RPM is the below base speed, so we should apply the armature voltage control to control the speed. So at 400 RPM, okay, so here we apply terminal voltage control, VT. I write here is VT, means that we control the speed by armature voltage control. So first, at rated we have a V terminal equal to 220 volt. Okay, we have armature current equal to 200 ampere. Okay, so RA equal to 0.05, RA equal to 0.05 ohm. Okay, so first we calculate the EA. So EA equal to VT minus IA RA. VT is 220 minus IA equal to 200 times RA equal to 0.05. So we get here EA equal to 210 volt. And then okay, we find the torque here. Torque equal to K flux omega, and then we know that E equal to, and then we have E equal to K flux omega. Sorry, torque equal to K flux IA. So K flux equal to E over omega. E over omega times IA. Why? Because we have the value of E here, and then we have the value of, we can find the omega, and then we have a IA. So torque at rated equal to, okay, omega equal to 2 pi n over 60. So here we get 2 pi n 750 over 60 equal to okay, I leave it here. Okay, so we get here E over omega. You calculate the value of omega. So E equal to 210, IA equal to 200. So you get torque equal to 534.76 Newton meter. Okay, from here at 400 RPM, okay, so we can calculate the torque L here equal to 500 minus 0.25 N equal to 400. So we get torque L equal to 400 Newton meter. Okay, and then E2 equal to, okay, how to find the E2? We can use this equation, E1 per E2 equal to N1 per N2. So E2 equal to, E1 is 210, N1 is 750, N2 is 400 RPM. Okay, flux is constant, okay, because we control the speed by terminal voltage control. So E2 you will get 112 volt. Okay, then how to calculate the terminal voltage? So from here, Vt equal to E2 plus Ia Ra. So E2 equal to 112 plus Ia. So Ia here is Ia2 Ra. But we do not calculate yet the Ia2. So to find Ia2, we can use the ratio between torque 1 per torque 2 equal to Ia1 per Ia2. Okay, so Ia2 equal to torque 2 per torque 1 equal to Ia times Ia1. So torque 2 is torque L, which is 400 Newton meter. 400 divided by torque 1 534.76. Okay, 76 times Ia1. So Ia1 equal to 200. Okay, the answer is 149.5 ampere. So you substitute in this equation Ia2, so you will get Vt2 is equal to 119.48. Okay, next. So calculate the value of flux as a percent of rated flux when the speed is 1500 RPM. Okay. This is B. Okay. First, at 1500 RPM. Okay, you know that when the speed is above the rated speed, so we control the speed by controlling the flux. Okay, so means that Vt and Ra is fixed. Fixed means that the terminal voltage is as the rated value, which is 220. Okay. So first we calculate the torque 3. Torque 3 rated is first condition, 400 RPM second condition, and then for 1500 RPM is third condition. So torque 3 equal to 500, okay, minus 0.25 times 1500 RPM. So here we get 125 Newton meter. Okay, and then we have an equation Vt equal to, so now I put as E3. Okay, E3 plus IA3 RA. Okay, and then now, okay, why IA3 is changed? Cannot take as a rated current because the torque is changed. Okay, the torque rated is 534.76 and the torque 3 is 125 Newton meter. Means that we have a relationship between torque and current. Torque equal to K flux, torque equal to K flux IA. So bila torque berubah, IA pun akan berubah. Okay, that's why here I put IA 3. Okay, and then E3 equal to, we know E equal to K flux omega, okay, omega 3 plus IA3 RA. So omega 3 equal to 2 pi n over 60, where n equal to 1500 RPM. So we get omega 3 equal to 157.08 revolution radian per second. And then from here, K flux, we have an equation torque equal to K flux IA. Okay, because we want to find the IA, so IA equal to torque over K flux. Okay, sorry, we want to eliminate the K flux. So K flux equal to torque over IA because we know the value of torque 3 and we want to find the IA 3. So K flux here equal to torque 3 over IA 3 times omega 3 plus IA 3 RC. So the terminal voltage same as the rated because it is fixed. Okay, we just control the terminal, we just control the field current, but the terminal voltage is at armature is fixed. So from here we have a V3 equal to 220 equal to torque 3 is 125 divided by IA3, okay, omega 3 equal to 157.08 plus IA3, okay, plus IA3 times RA equal to 0.05. From here, okay, so if you solve this simultaneous equation, you will get IA3 equal to 4.309 kilo ampere and 91.14 ampere. So this value is very high. So we take this value for IA3. Okay. Now the question asks to calculate the value of flux as a percent of rated flux. Means that we use this equation torque 1 over torque 3, okay, equal to K flux 1 IA1 over K flux 3 IA3. Okay, and then from here, okay, K K flux 1 over K flux 3 okay, calculate the value of flux as percent of, sorry, so K flux 3 over K flux 1 equal to IA1 divided by IA3 times top 3 over top 1. Okay, so IA1 is 200. Okay, IA3 equal to 91.14 times top 3. Top 3 is 1 to 5 divided by top 1 is 534. 534.76. So we get here equal to 51.3%. Okay, why K flux 3 over K flux 1? Because the question asks to calculate the value of flux as a percent of rated flux. Value of flux 3 as a percent of rated, which is the flux 1. So this is the answer.